trivia quiz. Hopefully it will be in focus, but you are looking at one of several posts to come regarding various subjects of interest. There will be no significant on-screen pause before the answer because that's what the pause button is for. True or false? A trained skydiver, all things being equal, has a better chance of surviving an air disaster because he or she is trained to roll into the impact. The answer is false. The roll into the impact is called a PLF, or parachute landing fall. Parachute is the operative and relevant. You see, parachute is the operative and relevant qualifier. A PLF is similar to a stage fall and is performed to prevent injury during a landing under a round normally functioning parachute or a botched flare-out under a rectangular paraglider. Granted, people have on rare occasions survived terminal velocity impacts into yielding surfaces. This is almost always involved being slowed down by tree branches and or hitting deep snow. In some cases, punching through roofs of barns and other structures is said to have saved them or delayed the onset of their deaths. PLF maneuvers may or may not have helped, but what I'm emphasizing here is that is not what the training is designed for. At least not during the time that I was jumping a few decades ago. The best way to survive a terminal velocity impact is to avoid one. The next question here is, which is more delta V friendly? In other words, which will help a spacecraft reach higher speeds? Is it higher thrust or lower thrust? Okay, lower thrust. That is the answer. There are two major criteria for maximizing speeds that a spacecraft can accelerate to, that is, rocket engine-wise. Specific impulse, which is the ratio between thrust and propellant flow, which is directly proportional to the final propellant velocity. And there's also mass ratio, which is the mass of propellant over the mass of the spacecraft, either when it's empty or after a burn. The more thrust being produced, the more g-force is being imposed on the spacecraft structure. This necessitates a more robust, therefore heavier structure. About the only time thrust is necessary in spaceflight is about the only time that high thrust is necessary in spaceflight is from surface to orbit, where there's a lot of gravitational and or atmospheric drag to overcome. A spacecraft best suited for a high mass ratio may not hold together on the way to orbit under the g-loads involved. So it might be that to assemble such a craft may have to be assembled and fueled in space. If that's possible, and it probably would be the only way. Once in space, thrust is of very little importance in terms of delta V potential, as a craft can accelerate as long as thrust, however slight, is being produced.